You're asked to write a full explanation of what domain restrictions are and why we have them or don't when dealing with inverses. So basically the two that we've really talked about in length are functions where we're dealing with quadratics and functions when we're dealing with cubic. Now, again, we could go on and talk about quartic and so on and so forth, but really domain restrictions, basically why we would have them when we're taking the inverse is if we're looking at a parabola, a quadratic, anything that has this general shape, no matter where it lands on the graph, if we were to take this and we were to flip it across the line y equals x, because that is what the inverse does to a graph. If we flip it over any of that, basically what happens to our graph is it becomes this sideways U. Again, depending on where it is, it may move around a little bit and maybe get wider or thinner, but it's going to be this sideways U or a C looking like thing. And when we take this and we make it into a C, what happens is that the inverse of the quadratic is no longer a function because it has two outputs for a single input, or two y values for one x value. So the reason that we have a domain restriction is because what we need to do is we need to cut our parabola in half. And when we take the inverse, we're only looking at the right half so that when we look at the inverse, we're only seeing this red line here, which is still a function. So when we take the inverse, we need a domain restriction only for quadratics because the inverse is not a function. When we're dealing with cubic functions, the reason we don't need to worry about cubic functions is because cubic functions look kind of like this. When we flip them over the line y equals x, they now look like this, but at no point is there two y values for a single x value, meaning the inverse of a cubic function is still a function. So we do not need a domain restriction.